Hi students, this is for Future Doctors NEET Academy. Welcome to problem solving session in NEET Physics. Today's topic is chapter 3, current electricity. Today we are going to give 7 questions and tomorrow, that is next day, we are going to explain about the solution about these 7 questions. Let's move to first question. The effective resistance of a series connection that consists of 4 wires of equal length, equal area of cross section and same material is 1 ohm. What will be the effective resistance if they are connected in parallel? Option A 0.25 ohm. Option B 0.5 ohm. C option 1 ohm. Last option 4 ohm. So here effective resistance when 4 resistors connected in series is given, that is 1 ohm, and with one condition, that is all the 4 wires having same length, same area of cross section and made up of same material. Now, what will be the effective resistance if they are connected in parallel? Parallel. Let's move to second question. Question number 2. The resistance of a wire is R ohm. If it is melted and stretched to n times, that is n number of times, its original length, its new resistance will be dash. Option A, n times of R. Option B, R by n. Option C, n square times of R. D option, R by n square. So your question is, R ohm is given, one resistance of the wire, that is just R ohm is given, and same that material, that is when it is melted and stretched to n number of times, n may be 5 times or 10 times, n equal to 5 or n equal to 10, we are going to apply. So n number of times, then what will be its new resistance? That may be R dash. R dash in terms of R you want to find. Okay. Next, move to third question. Question number 3. The mean free path of electrons in a metal is 4 into 10 power 8 meter. The electric field which can give on an average 2 eV energy to an electron in the metal will be unit of dash volts per meter. Option A 8 into 10 power 7. Option B 5 into 10 power minus 11. C option 8 into 10 power minus 11. Last option 5 into 10 power 7. Remember all these things in given unit called volt per meter. Volt per meter is given and average energy is given in 2 EV. EV means electron volt. So before applying this, you have to convert into SI unit. I think EV is not a SI unit. You know which is a SI unit of energy. You should convert and then proceed. Next question, that is question number 4. Fourth question, if a wire of resistance R is melted and recasted to half its length, then the new resistance of the wire will be dash. Option A, R by 4. Option B, R by 2. C option, 4 times of R. D option, 2 times of R. So here R is a actual original resistance of the wire, and when it is melted and recasted to half of its original length, then the new resistance R dash you want to express in terms of R. Next question, question number 5. Fifth question, two cities are 150 kilometers apart. Electric power is sent from one city to another city through copper wires. The fall of potential per kilometer is 8 volts and the average resistance per kilometer is 0.5 ohm. The power loss in the wire is dash. Option A 19.2 watt. B option 19.2 kW. kW means kilowatt. C option 19.2 MW. MW means megawatt. Last option 1.92 watt. And here given data is distance between the two cities as given, that is 150 kilometer, and fall of potential is 8 volt per kilometer, and resistance also, average resistance is 0.5 ohm per kilometer is given. Now you want to express power loss in terms of watt. Okay. Next question, question number 6. The internal resistance of a 2.1 volt cell, which gives a current of 0.2 ampere through a resistance of 10 ohm is dash. Option A 0.2 ohm. B option 0.5 ohm. C option 0.8 ohm. Last option 1.0 ohm. Your given data is 2.1 volt, that is EMF is given, and current 0.2 ampere is given, and resistance of the cell is given, that is 10 ohm, and you want to find the internal resistance of a cell, which is in ohm only. Next question, this is the last question, 7th question. A potentiometer consists of a wire of length 4 meter and resistance 10 ohm. It is connected to a cell of EMF 2 volts. The potential gradient of the wire is dash. Option A 0.5 volt per meter. B option 2 volt per meter. C option 5 volts per meter. Last option 10 volt per meter. Your given data is length of the wire is given 4 meter and resistance is given 10 ohm, and EMF of a cell is given, that is 2 volts. You want to find the potential gradient. So before applying this, as usual, check all the data given here is SI unit or not, and then you can apply. Okay, so this is the 7 questions for today's session, and tomorrow's session we are going to give solution. Before that, students can solve this, and in comment session during tomorrow you can give the solution or answer for each questions. Okay, thank you.